I'd like to explore in more detail now the various kinds of expressions you can use in MaxScript. These include not only math expressions, but also comparison and logical expressions and other more complex forms. Recall that anywhere you can put a simple value, for example as a function parameter or a value or property assignment value, you can put an expression that computes a value. Okay, first math expressions. These are the familiar algebraic expressions made up of simple values, operators like plus and times and divide, and function application. The 5 math operators are shown here in these examples. Plus and minus, the same as in math, an asterisk for multiply, a slash for divide, and a caret for raising to the power. This says 2 to the n. This stylized form of math expressions is employed so they can be written on a single line with just the standard characters on a computer keyboard. The order in which the operators are applied is exactly the same as in normal algebraic expressions. So, in an expression like this, multiplication and division are done before addition and subtraction, and exponentiation is done before all of them. If there are no parentheses forcing an ordering, it is evaluated like this. First the exponent, then the multiplier, then the plus before the minus, because they have the same precedence, but associate from left to right. Function calls have the highest precedence, so the earlier example evaluates in this order. Note especially that it is b divided into the sign of x, not the sign of the division of x by b. To get that, you'd have to explicitly parenthesize the x over b. This is a very common source of error when writing expressions containing functions. Any parameters to a function call that are themselves subexpressions must be enclosed in parentheses. Here's another example of this using the atan2 trig function, which takes separate rise and run parameters. I had to parenthesize both parameter subexpressions so they'd be computed before being passed to the atan2 function. All the precedence rules are described in detail in the Precedence and Association Rules topic in the help file. The sign and atan2 functions in the last examples are part of a library of built-in mathematical functions listed in the number value topic in the help file. As you can see, there are functions for trigonometry, log, power, random number generation, and so on. And you can of course also write your own custom math functions. Most of the math operators are generic. They work not only on integers and floating point numbers, but have methods for other classes like text strings and vectors and matrices and even geometry objects. They do different things when used with these various classes, so plus on text strings concatenates them, and minus on geometry objects does a Boolean mesh subtraction. Perhaps the most powerful examples of these generic operators for max work are the math operators available on vectors and matrices and quaternions. They let you do 3D linear algebra in concise algebraic expressions. Now, linear algebra is a whole topic unto itself, but let me talk quickly through a couple of simple examples so you get a feel. The first statement computes the coordinates of the midpoint between two objects by computing the average of their position vectors. The plus operator here is doing vector addition on the position vectors, and the slash operator is doing vector division by a scalar. You could use this expression to help place an object exactly midway between two others, for example. The second pair of statements figures the delta vector between object 2 and object 1, and then sets object 2's position to be 3 times further away along the same line. MaxScript also supports the operator assignment shorthand that is common in other programming languages. These let you write common updating forms, such as x equals x plus 1, as x plus equals 1. The plus equals operator here is something like a combination of a plus and an assignment, and essentially says add the value on the right-hand side to the destination on the left. Here's another example using multiplication to bump a light's multiplier parameter. It can be written like this, with the times equals operator. Generally, if the assignment statement is of the form something equals that same thing, plus or minus or times or divide something else, you can use the operator assignment shorthand.
which saves a bunch of typing and is often clearer.
One of the things you can use in expressions and elsewhere is the property axis construct we've encountered several times already. These are somewhat like variables in that they can be used both as sources of values or destinations to assign a value. Generally, a property access uses the dot operator on a value, and that value itself can be another property access, so you can chain down through a nesting of properties.
For example, this says, access the material property on box 1, get that material's diffuse color, and then get that color's hue component. You can string as many of these nested properties together as you need, and of course you can use them as destinations in an assignment statement as well. The value that is originally being accessed can also be an expression in parentheses, like this, for example. This calls the built-in function getMeditMaterial to retrieve the material in the first slot in the material editor, and then acts as the diffuse map within it, and sets that map's RGB output parameter to 0.5. Another kind of expression is the comparison expression, used for comparing values in a test expression. There are 5 comparison operators in MaxScript, shown here. Note that the equals operator is written as a double equal sign to distinguish it from the assignment operator, and the not equal sign uses an exclamation mark equal sign as its symbol. Here are some examples. You can see that the values being compared can be simple values, or they can be arbitrary expressions themselves. The equality operators will work no matter what class of value you compare, but the magnitude operators will only work on comparable values. For example, you can compare numbers with numbers and strings with strings, but not numbers with strings. The result of a comparison is always one of the 2 special values, true or false. These values are themselves instances of the class named Boolean.
You will also encounter Booleans when working with checkboxes and check buttons in rollout dialogues. These controls have a state property that holds the current check state, and its value is true for checked or false for unchecked. There are also many Max object properties that appear as checkboxes in their parameter rollouts, and these also have Boolean values in MaxScript, true for checked or enabled, false for unchecked or disabled.
As an example, say I have a box in a scene that is animated along a path with a path controller. Here's the path controller page in the MaxScript help file. You can see there are many Boolean properties corresponding to the checkbox parameters such as bank and follow. If I access one of these, say bank, you see it yields a Boolean, false in this case, because bank is turned off in this controller. If I assign a Boolean value to one of these properties, say setting follow to true, you see the box now follows the path, and the follow checkbox flipped on in the motion panel. Sometimes a conditional clause in a script will require a combination of tests, not just, say, a single comparison.
For example, I have a script that is running over the objects in a scene, applying a certain material to all the boxes whose height is less than 10 and all the spheres whose radius is less than 5, a crude kind of MIP mapping.
You can see the if test clause here has 4 comparisons combined with ands and ors and nots, as you might in English. This whole thing is called a logical expression, and the ands and ors and nots are the logical operators. In this example, there are no grouping parentheses to say which order to evaluate things, so the standard precedence is used. Ands before ors, and nots before either of them.
Note also that the comparison operators have higher precedence than the logicals, and the math operators higher than both, which yields the natural ordering we expect in math and English. All this means the logical expression in our example evaluates this way.
Comparisons first, then logical nots, then logical ands, and finally logical ors. And here's another example with all kinds of operators. It evaluates this way. First, the math operators, then the comparisons, then the nots, then the ands, and finally the ors.
MaxScript optimizes the evaluation of logical expressions, As soon as it knows an answer, it does not evaluate any other terms.
In the previous example, if the class of the object is not a sphere, it won't even try to evaluate this comparison. Because of the AND relationship, both terms have to be true for the entire AND expression to be true. And anytime the first one is false, it doesn't need to check any further. This is actually very handy in this case because there are many object types that don't have .radius properties, and this radius property access could cause the script to fail if it was applied to every object. The first test acts as a kind of filter or guard for the second when joined with an AND operator. An assignment is also an expression and yields the value assigned as its value. This means you can cascade assignments like this, which assign 0 to each of the 3 variables. You can also embed parenthesized assignments inside expressions like this. Here, I'm both checking if the sign of x is greater than 0 and grabbing it into the variable y so I can assign it in the then branch. The final kind of expression I want to introduce now is the conversion or casting expression. This lets you convert values from one type to another using the as operator like this. The as operator takes a value to convert as its left operand and a class to convert it to as its right operand. Here, for example, converting a floating point number to its character string representation. And here, converting from a string back to a number. This last example shows a quaternion rotation, which is Max's internal representation for rotation values, being converted to an Euler XYZ value, on which I then access the .x property to get the box's rotation about the x-axis. In this case, I had to parenthesize the as conversion, since the .property operator has a higher precedence than the as operator. Clearly, knowing the precedence of all these constructs is important when writing expressions, so I'll summarize the complete order here again. This list shows the order of evaluation of these constructs when used together in an expression. At the top, with the highest precedence, are the simple values, collectively known as factors, including variables and literal numbers and strings and vectors and so on. Then come parenthesized sub-expressions, then the dot notation property access and array indexing. These are left associative, which means that if there are several of them used one after the other, as in nested property access, they evaluate left to right. Next is the unary minus sign used as a prefix operator to negate a value, then function calls, then as conversions, then exponentiation, which alone is right associative, meaning a sequence of exponents is evaluated right to left, just as in conventional math. Then comes times and divide, then addition and subtraction, and they are also left associative, which means they evaluate left to right. Lower precedence still are the comparison operators, then logical NOT, followed by logical ANDs and ORs, and then finally assignment.